All right, here is the speed run of Sunlight, the July 2026 Road to Las Vegas case. I'm gonna start. I got an X in lambda there is just converts numbers as strings to numbers, but leaves the strings alone. So that, just grab the first one of those for level one, and then sum them up for level two. Then in level three, I need to know, so these are the trees. I need to know the side of the square, right? What's the side length? So the square root of the rows of this is how big it is on a side. Addresses, and I want to use my numeric addresses here, right? So it is A1 and then something. And let's see what it's going to be. So it's going to be the string address of the numeric address, right, is 1,000,000 times the row number plus the column number, right? So those are the numeric addresses. It's also known as A1 to C3. But I'm doing this a little bit, I'm not assuming it's 3 by 3 because I want to use this later when it's not 3 by 3. So now I'm just looking up the sun, or here, let's do sun symbol is S, right? So X lookup this on here, returning here, right? And that is the sun address, which I'm going to need later, so I might as well do that this way. And then the string address of this is our answer, right? 3,000,002 is B3. All right, so now I need the path of the sunlight. So the direction also has a numeric address, right? So the up arrow is -1,000,000. So you add -1,000,000 to get the next one. So this is what I'm going to do. So I scan start. So, the path, right, is scan starting at the sun's location. The array is just the number of times I'm doing it, which is side -1. So 2 in this case, right? 3 minus 1. And then the function, lambda ax of a plus x. Right? So that's the path there. No, not x. A plus the direction, like that. Yeah, okay. So now the trees on path is look up this on here, returning here, and if it's missing, we'll count that as a 0 height. The max so far, right, is scan starting with 0, this array, and I want the function to be lambda ax, the max of a and x, but I also need an if error because for some reason it gets confused if there's a string in it, which I can't handle. So if it's error, then just carry over the a to be the max. All right, so that's the max so far, and so the previous max is actually what I care the most about, right? So I'm going to shift this array down 1 and fill in a 0. Right? So is it lit? So we check to see, is the tree bigger than the biggest tree so far, the biggest tree prior to this one, right? And then I'll just, make those 1s and 0s. And then over here is lit. So exists on, or no, I'm going to do, these are the lit cells, right? Oh, except I don't even care about what's lit in this case. I just need the height of the trees for level 4. I'm already doing level 5. All right, so this is the height of the trees, which is level 4. Then I'll pick this up for level 5. All right, so for level 5 now, we've got the lit cells is look up. So filter, I've already got the cells here, so filter those based on whether they're lit or not. If it's missing, just give me an empty. Now exists on this thing here. And then I need to sum up the filter of the trees based on them not being lit. So the lit equals 0. All right, so that's level 5. I want to make this a lambda now, right? So the inputs to the lambda, I mean, these two are obvious, right? The forest input is sunlight direction. I have to highlight those so OA robot doesn't go back to the start. And also the other thing is the sun symbol because that changes in level 7. So now that I've got the inputs, SLA, save lambda as, and here is my lit cells lambda. And this should do level 6 and level 7 for me. So now instead of, calculating it, what I'm going to do here, I'm going to use my lambda to calculate it. Get rid of that. Is what is, lit 1 and lit 2 is lit cells with this forest input. The left of this for this direction, the sun symbol is S in this level. All right, so that is the lit for one direction. This is the lit for the right arrow. Then all is V stack these guys. Doesn't matter if there's duplicates. And then the exists, right, needs to check on this one. Exists like that. And then that's going to give us, it's the same unlit ones here. Here it's S1 for the first two directions, right? And then it is the same thing, but S2 for the second sun, right? So now the sun is called S2. The left for S2, and it's got to be the left of the S2 arrows like this. And then the right of that and the S2 arrows is there. And then all of them includes this and this. All right. So that should be good for level 7. Check answers so far. Yep, 1,000 points. Sum of all the trees in levels 1 to 5. Well, I guess I could put that here. Seems like an okay place to put it. And then it is, let's just take this formula rather than rewriting it. Is extent of text split of this, and then sum. Right, copy that down to levels 1 to 5, and then copy the sum here. Popular location of the sun, right? So I've got my sun location is level 4. No, sun location is level 3. All right, so I'm going to take these inputs here and put them in. Well, what if these were the inputs to level 3? So do that based on the column input cell being there. And then the frequency table of this will give me the most common one, which is C2. Which cell never in level 5 never receives sunlight. So which ones do receive sunlight? First of all is save array of this. And now save array of this array, please. Yes, like that. All right. So text join these by the, and you got to put the delimiter first with text join by the semicolon, like that. So now I'm going to split them back up and then do set difference, right? So equals set difference of the starting set is all of them, right? And then I subtract out those, leaving only that except for these have got to be numbers like that, right? So the only one that is never used is 2002, right? Which is B2, 2,000,002. All right. How many times did a tree of height 7 receive sunlight? Well, what trees do receive sunlight is this. So save array like that. So again equals. So these I'm just going to pull out like this. And then again, I'm going to text join by the semicolon, all of them. Text join by the semicolon, all of them. Then text split this by the semicolon. And then what? Count if this equals 7 is 5. I guess that's what it, but that would, you know what? I could have done that much faster way, but I didn't. All right. Finally, we're going to do what if all these were, what if the arrows all went the same way in these? All right. So first of all, I'm going to use the cycles. So the outer end is 4 and the inner end is 20 because there's 4 different directions, 1, 2, 3, and 4. So the directions are up, down, left, and right here. And then, equals this and itself, just to double them. And then I'm going to double it again like that. So those are the directions. So this is, direction in game in the field and the directions, right? So the field is the index of these. Is this the last one? No. The index of these 20 fields, right, by something. So this stays locked. And then the something is that game in, right? And then the directions is X lookup this on here, returning on both of these, like that. And then if I copy this down, and then say, this is the row number, so let's say it's row number 1, then what's going to happen is equals the index of this data here, right, by the row number, and all the columns is there. So now I just need to do this, 80 times. And this now is data table based on this being here. All right, and now I do the filter of this, right, based on this being something, right, which I'll do in a second. This being equal to there with these guys locked, right? So that is all the games if it's going up, down, right, and left. The one of these that is the smallest is 2081. Up we go. 2081. That's it. Oh, forgot to do the timer, but YouTube will tell you. That's it. Thanks for watching. Bye.